All right, so where might a limit exist in real life? So this is Nina. Nina develops a recipe for caramel chocolates and provides samples of the chocolates to many of her friends. Within weeks, she begins selling the caramel chocolates for $6 per pound. She offers a 20% discount if the customers buy 2 pounds or more. So the pricing model is if you buy less than 2 pounds, you're paying $6 per pound. If you buy 2 pounds or more, you get the discount of 20%. And I think that's right because 6 times 0.8 is 4.8. So you get $4.80 per pound as long as you buy in bulk. So we're going to sketch the graph of this piecewise function from 0 to 5 pounds. So to sketch a piecewise function, what I would do is I would plug in 0, 1, and 2 into the original function, $6 per pound, right? So if you buy 0 pounds, you're going to spend $0. I wonder if this will have enough room. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I should probably count by maybe $2 at least on the, what is, that would have to get to 30. 6 times 5 is 30. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 23, 46. Okay, let's count by $2 over here. 2, 4, 6, 8, right? So if I buy 1 pound of chocolate, I'm going to spend $6, right? I'm going to connect this with a line in a minute. All right, this says P has to be strictly less than 2, but let's pretend I buy 2 pounds. How much would I spend? I'd spend $12. 6 times 2. 2, 4, 6, 8, 10, 12. Oh, but I'm going to put an open circle there, right? Because I don't really have a point at 2. So this is a straight line. It has a slope of $6 per pound, right? So if I buy half a pound, I'm going to spend $3. But I have an open circle at 2 because at 2 pounds, I get a discounted rate. So then what happens? At 2 pounds, I start getting my discounted rate, right? So if I buy 2 pounds of chocolate, I actually get to use this bottom equation, and I do $4.80. $4.80 times 2 pounds. So that's only $9.60. So at 2, I'm only spending $9.60 down here. And then what am I spending at 3? So for 3 pounds, I do 3 times 4.8, which is 1440. So let's try to graph 1440. 2, 4, 6, 8, 10, 12, 1440. And then what's 4 times 4.8? 1920. 4, 6, 8, 10, 12, 14, 16, 18, 20. So 19 is about there. 5 times 4.8 is 24. 6, 8, 10, 12, 14, 15, 18, 20, 24. All right, so I made it. So this is my piecewise function. And you spend $6 per pound for less than 2 pounds. Then you get a discount and you only have to spend $4.80 per pound from 2 pounds on. So I want you to use the functions up top or the graph to see if you can answer questions 1 through 5 down below. Like, what if you buy 1.5 pounds, what's the cost? Or 2.5 pounds, what's the cost? If you had $20, how much could you spend? And then tell me something about those limits on 4 and 5. So see if you can answer 1 through 5, and then we're going to talk about the answers and look at the back page together. That 9 and then 12. Do we get the same thing? Because the 1.5 gets plugged into the first equation. So I did 6 times 1.5. But the 4.8, or sorry, the 2.5 gets plugged into the other equation. So I did 4.8 times 2.5. And then $20, I used the 4.8 equation, and I got about 4.17 pounds or 4.16 pounds. And then the limit at 1, the graph is approaching the same value on both sides, so I said the limit was 6. But the limit at 2 is a problem because we're approaching 12, but we're also approaching whatever this was, 9.6. So the limit does not exist at 12, or sorry, at 2. And that's where the problem comes in. So this person's customers start to complain. So on the back page, now the customers are complaining. It says, one day a customer complains, it costs less to buy 2 pounds of chocolate than it does to buy 1.9 pounds. So Nina decides to develop a model that provides a discount, but that addresses the customer's complaint. In the revised model, we want to find that value of k that will make the function continuous at p equals 2. So what they want to do, it's kind of hard to tell in my graph, but this line has a slope of 6. This line has a slope of 4.8. So you are getting a discount with your slope. They basically want to slide this graph up a little bit so that you paid $12, and then after you pay your $12, you get a discount on the remaining pounds. So what would k have to be so that when I plug 2 into this equation, I still get 12, right? When I plug in 2 up here, I get 12. I want to force this equation to start at $12, but then get a discount after that. So if you wanted to set up an equation, 4.8p plus k has to equal 12 when p is 2. So I can actually plug in 2 for p. So how much am I off by? What is my k value going to be to make this true? So what is 4.8 times 2? 9.6. So what does k have to be to make this equal 12? So it'd have to be 2.4. So my equation, my second equation is going to be 4.8p plus 2.4. And that will make it so that my graph starts at 12 and then has a discounted rate. So I'd like you to try graphing. The first equation is going to be identical as what we already graphed on the front page. The second equation, you're going to have to generate values for 3, 4, and 5 pounds and connect those dots using this new revised equation, 4.8p plus 2.4. So you're going to plug in 3, plug in 4, plug in 5, and graph that piecewise function, and then see how your answers, some answers will stay the same and some answers will change down below because of revising that equation. So basically they've slid that second line up to start at $12 and then continue with the discount. So you're trying to graph and find those answers. So if you're doing this at home, try it on your own first. So I got the first. From 0 to 2, it goes from 6, 12, right? And then the next graph starts at 12, and my graph got the points, and it ended at 5, 26.4, so there. Did you already find the answers, or are you still working on the bottom part? You found them? So 1.5 wouldn't change, right? This is still 6 times 1.5 was 9. But the second one would change, right? So now I have to do 4.8 times 2.5 pounds and add 2.4. Did you get 1440 for number 2? And then how many pounds could be used? So $20. We've got 4.8p plus 2.4. So you'd have to subtract the 2.4 first, and then divide by 4.8. So is that 3 2/3 pounds? That's what I got. 3.666 repeating. And then let's see, the limit at 1 is still 6. That didn't change, but now the limit at 2 is 12, right? Because now it's approaching the same value on the left and the right. That's what we just fixed. We made the limit exist.